Now I am going to cover multiple linear regression in this session. Myself, Dr. Akash Asthana, I am assistant professor of this department, that is Department of Statistics, University of Lucknow. While dealing with two or more variables, we have three basic questions. First question, is there any relationship between two or more variables? Second question, if the variables are linearly related. If yes, then what is the strength of the relationship? And if the variables are related, then what changes would occur in one variable when changes are made in other? The first question, that whether two variables are related or not, is answered by using a scatter plot. A scatter plot is used to detect whether two variables are related or not. To construct a scatter plot manually, we take one variable on horizontal axis, which is also known as x-axis, and other variable on y-axis, which is also known as vertical axis. Then we mark the point x comma y on the graph. That will be scatter. Generally, our more basic structures of scatter plots are of these type. First one, that is this one. Here you can see that all the points are on same line, and one variable is increasing, then other is also increasing. So this situation, we said that both the variables are perfect positively linearly related. In second situation, if one variable is increasing, other is also increasing, all the points are not on the same line. In that situation, we remove the word perfect. Variables are said to be positive linearly related. In third situation, that is in this situation, all the points are again on same line, but in this situation, one variable is increasing, then other is decreasing. So when all the points are on same line, we use word perfect. When all the points are not on the same line, we don't use word perfect. And if both the variables are moving in same direction, that is both are increasing simultaneously, then that is positive relationship. If they are in different direction, one is increasing, then other is decreasing, we said they are negatively related. So here in third situation, that is in this situation, one variable is increasing and other is decreasing. So there is a negative relationship. And all the points are on same line. So we said that it is perfect negative linear relationship. In fourth diagram, one variable is increasing, other is decreasing. And all the points are not on the same line. So we said that variables are negatively linearly related, but there is no perfect relationship. In fifth diagram, if one variable is increasing, other is parallel to the axis. That means there is no changes obtained. When
one variable is increasing while other is not
increasing, then the variable is constant, then it is called as no relationship among the variables. And it is an example of curvilinear relationship. We may get any other shape of curve that is called as curvilinear or non-linear relationship. That is, if we are changing in one variable, then other variable is changing, but relationship is not linear. In that situation, we said that variables are non-linearly or curvilinearly related. How we plot the scatter plot using SPSS. So for plotting the scatter plot, we go to the graphs, and there we select legacy dialogs. Then it will show you test command, and here we select the option scatter or dot. Okay. When we click on scatter or dot, will open another box which asks which plot do you want to move. So for performing the regression analysis, we use scatter plot. We select a simple scatter. If we have two variables, if we have more than two variables, we use matrix scatter. So in starting, I am considering only two variables. We start with simple scatter. Select simple scatter, or by default in SPSS, simple scatter is already remain selected. Then we click on define. Then on defining, it will open another dialog box, this one. Here you can see y-axis and x-axis. In one axis, we put one variable, on other axis, we put other variable. That is, first we select variable on y-axis, then we select variable on x-axis, then we click on, it will generate scatter. Let us move to scatter plot first, then we will move on further lecture. For this, we start SPSS. If you have downloaded the data, then it's okay. If you have not downloaded the data, go to File, click on Open, then there is option Data. Click on Data. It will ask from where you want to take the data. You will go to C drive. There is a folder, Program Files and Program Files x86. Old laptops have only program files. New laptops have program files and program files x86, both folders. So if you have older one, you select program files. If you have new laptops or new version of laptops, go to program files x86. Then there will be a folder IBM. Go to that folder. There will be a SPSS. Click, open that SPSS. Then statistics. Then folder, whatever version you have, that folder will appear. I think you will have folder 27. Double click on 27. Then there is a folder samples. This one. Open this folder. In this, there is another folder English. And this folder has a number of data sets from which you have to select the data set car sales unprepared. Okay. Select car sales unprepared and click on open. It will open your data sets. Everyone have opened the data sets? I There will also be in MacBook, you have to go to drive where your programs are installed. Then there you will be folder of IBM. From there you will get the and for all other, there will again I am repeating the steps. Go to File, go to Open, then Data. From there, go to Drive C. There will be program files or program files x86. Go to this folder. Then there will be a folder of IBM. Go on that. And there will be a folder SPSS. Then statistics, then 20. Then there will be a folder samples. Then there is English. In that English folder, you will have data car sales. Select that data and click on. Then for making the scatter plot, go to graphs. Click on legacy dialog. And there will be second last option, scatter or dot. Click on that. It will open a dialog box. Plot you would like to make. Select is simple scatter. Then click on define. Is it okay? Then take one variable on y-axis. I am taking 4-year resale value on y-axis. And horsepower on x-axis. And click on OK. Generate your scatter plot. Look like this. Okay. So in this scatter plot, you are seeing that if horsepower is increasing, then 4-year resale value is also increasing. But you can see all the points are not on the same line. So we can say that horsepower and 4-year resale values are linearly related or positive linearly related. That is, if you are increasing horsepower, then price will also increase. In regression, while constructing a scatter plot or correlation, we does not require which variable is dependent and which variable is independent. We can take anyone on x-axis and we can take anyone on y-axis. Now, variables are linearly related. Then the question is, how much strong the relationship is. But before going to that, we will make another plot. There is another option, matrix scatter. Okay, if you have more than 2 variables, that is one dependent and more than one independent variable, you can construct all the scatter plots in one diagram. That diagram is called as scatter matrix. So you can select the option matrix scatter and then click on define. It will open another dialog box called as scatter plot matrix. Here, put all the variables for which you want to construct a scatter plot in matrix variables. That is here. Then click on it. It will generate a plot like this one. Let us make an scatter plot. Chart builder, legacy dialog. Go to scatter or dot. Click on that. Then select matrix scatter. Then click on define. I am taking all the variables in matrix variable. Engine Fourier resale value, engine size, horsepower, wheelbase, width, length, or weight, fuel capacity, and fuel efficiency. Then click on it is generating this scatter plot. We are interested in Fourier resale value. Okay, that is if we are purchasing any vehicle, we are going to sell it after 4 years. Then what should be its price? That is Fourier resale value. It will depends upon several conditions. If you want to purchase any second-hand vehicle, what would you like to see in there? I want answer from you. What condition? How you will judge that condition? First importance, I think you will give mileage. How much kilometer it will go in 1 liter of diesel or petrol? What was its size? What is its power? How much it can bear the power? How much percent it can improve? Okay. What is the size of engine? What is the length of vehicle? What is the width of a vehicle? If you are 7%, then you will not like to buy 5% vehicles. Okay. So what is the size of vehicles? There are several variables which you would like to. So I have included that variables in our model or our scatter plot. So we take only line 4-year resale. Other will also consider, but that will be on later. When you construct a scatter matrix, you see that diagonal is empty. It is empty because it is showing the scatter plot of variable with itself. So that is not required. If Fourier resale value is increasing, then it will always increase. So it is not required. We are not interested in relation with its own. We are interested with relation with other variables. So diagonal is empty and this one is showing the relation of Fourier resale value with engine size. Second one is showing the relationship of a Fourier resale value with horsepower and so on, all the variables. So if you can see, you can say that horsepower is linearly related. Other are haphazard, you cannot judge in scatter matrix whether these are linearly related or not, because all the points are concentrated on same point. So now the question is that if there is linear relationship, then what is the strongness of the linear relationship? For that purpose, or we can say for the strongness of the relationship, we use correlation coefficient. Generally, it is called as Karl Pearson's correlation coefficient or product moment correlation coefficient. It always lies between -1 and +1. While using the software, we are not interested in the formula. That's why I have not written any formula in my slides. So for interpreting what is the value -1 indicates, what is the +1 indicates, and what values lie between -1 and +1, then what should be our interpretation? So value of 0 indicates that variables are either independent or non-linearly related. Okay. If variables are independent, then that correlation will be 0. If variables are curvilinear or non-linear relative, then also we will get R is equals to 0 or very much near to 0. So if R is 0, we cannot say that variables are uncorrelated or independent. In that situation, we see the scatter. If line is parallel to x-axis, we said that variables are uncorrelated. If we are getting the shape of some curve, then we say that variables are non-linearly related. If value of correlation coefficient comes out to be smaller than 1, then we said that relationship is negative. Sorry, smaller than 0, then we said that relationship is negative. That is, one variable is increasing, other is decreasing. And when we get value of correlation coefficient larger than 0, we said that variables are positively related. That is, one is increasing, other will also increase. Now, it is the interpretation whether variables are positively related or negatively related. But if we are getting value 0.75 and value 0.5, whether the interpretation of both same or different. So for that purpose, we use second criteria, which are mentioned in 0.45 and 6. If the correlation coefficient comes out to be smaller than 0.3, whether it is positive or it is negative, we said that correlation is slight. If it lies between 0.3 and 0.75, whether positive or negative, we said correlation is moderate. And if it is larger than 0.75, we said that variables are highly correlated. Instead of it, some person use criteria less than 0.35, 0.35 to 0.8, and more than 0.8. It depends upon us. It is non hard and fast rule that you should use this criteria or that criteria. So if we are getting the value of correlation coefficient, suppose minus 0.59, what should be our interpretation? So negative sign, that indicates variable are negatively related, and 0.59, that is between 0.3 and 0.75, so it is moderately correlated. So we said that two variables are negatively, moderately, linearly related. Okay. So how we would obtain the correlation using SPSS? For obtaining correlation using SPSS, we go to analyze. Then we go, there is the option correlate here. In that, there are a number of options, among which we select bivariate. On clicking bivariate, you will get a dialog box open. This one. Then there is a box variable. Here you put the variables for which you want to obtain the correlation. By default, the first box, that is this one, shows all the variables in your data set. From that, you have to pick the variables of interest and to be put in the variables box. Then by default, it selects Pearson's correlation. We require no change. Okay. Then click on OK. That is here. It will give you correlation coefficients like this. Okay. Let us calculate the correlation between two variables and then more than two variables. Go to file, then to analyze. There is option correlate. Then it will show you bivariate. Click on that. In starting, we have constructed the scatter plot between horsepower and Fourier resale. So first we take Fourier resale value as variable and horsepower as other variable. Okay. Then click on OK. So you are getting these values. You are getting this value 0.769. Now what should be its interpretation? Positively, highly linearly related. Okay. There are two more things are represented in the table. Pearson's correlation, significance, n. N is the number of observations or number of pairs of observations used for the calculation of correlation coefficient. So in our data, we have used 120 observations. Okay. Pearson's correlation is 0.769. That means highly positively linearly related. Now, what is significance? There are concept of inference to generalize the thing or statistic for the population. So for your population, whether correlation coefficient is 0 or not. So we take the null hypothesis that correlation is equals to 0 and alternative correlation not equals to 0. If significance, which is also known as p-value, comes out to be smaller than 0.05, we said that null hypothesis is rejected or alternative is true. So our alternative is that the correlation is different from 0. So we can interpret that our correlation is also significant. In same manner, we have constructed the scatter plot, then scatter matrix. In same manner, we can use many variables simultaneously to get their correlation in one table. Instead of making different correlation table between Fourier resale value and horsepower, then Fourier resale value and engine size, we can take all variables in one. So go to file, then go to analyze, correlate, bivariate. Put all the variables you want to take, consider for study in variables. Okay. Then click on OK. So you can see that first column is for Fourier resale value. Similarly, first row is for Fourier resale value. Again, the diagonal elements are correlation of variable with itself. It will always be 1. All the diagonal elements in the matrix, you will see that are 1. So the relation horsepower and Fourier resale value correlation is 0.769, that is highly positively related. Engine size and Fourier resale value 0.531, that is moderately positively linearly related. Wheelbase and Fourier resale value minus 0.05. That means that you can say that weakly or slight correlation or variables are uncorrelated, very much near to 0. Okay. So in this manner, we can interpret the correlation between all the variables. And if you will see that fuel efficiency is significantly correlated, fuel capacity is significant, showing significant correlation, weight is showing significant relation with Fourier resale value. So in this manner, we calculate the correlation among the variables. Now the question is, if variables are linearly related, then what changes would occur in one variable if changes are made in other variable? That is answered with the help of linear regression. But in linear regression, to correlation and scatter plot, we does not using the concept of dependent variable and independent. In regression, we divide the variables into two broad categories. One is called as dependent, other is called as independent. Dependent is the variable in which we want to study the changes. Okay. And the variables which are causing the changes are called as independent variables. Dependent variables are also known as response variables, outcome variables, prediction or control variables. And the variables which are causing the changes, that is independent variables, are called as predictors, regressors, explanatory variables or control variables. Okay. Explanatory, that is which are helping to explain. Explain variables, that is which we want to explain. In same manner, controlled variable, that is which we want to control. And control variables which are already in our control. Okay, so variables which we are controlling are called as control variable or independent, or in other words, which you can say which are causing the changes in other variable, that is independent. So for linear regression, we have one dependent, which has one independent more than one independent. If we are using one dependent and one independent variable, the regression is called as simple linear regression. And if we are using one dependent and more than one independent variables, that is 2, 3, 4 variables as independent, then we say it is multiple linear regression. The general model for regression analysis is given by dependent variable is equals to linear function of independent variables plus error. Now, what is error term? Some variables are causing the changes in one variable, that is dependent variable. So you can say independent variable are causing some changes in dependent. But there may be a chance that the complete variation in dependent variables cannot explain with the help of independent variable. So the portion which remains unexplained, that is called as error. Is anyone has problem with English? Okay, so I may continue in English or Hindi is required. Bilingual. So the main issue is that कुछ वेरिएबल जो चेंज कर रहे हैं दैट आर इंडिपेंडेंट, जिसमें चेंज हमको स्टडी करना है दैट इज डिपेंडेंट. नाउ अगर हमारे पास एक डिपेंडेंट एक इंडिपेंडेंट है तो हम कहेंगे इट इज सिंपल लीनियर रिग्रेशन. अगर एक डिपेंडेंट और एक से ज्यादा इंडिपेंडेंट वेरिएबल है तो हम कहेंगे मल्टीपल लीनियर रिग्रेशन. More than one independent, not dependent. If we are using more than one dependent, then that is a different case that you will study in canonical correlation. Okay, that will be covered on third. For linear regression, we have model dependent variable equals to linear function of independent variable and error term. Error term डिपेंडेंट वेरिएबल का वो हिस्सा है जिसको हम इंडिपेंडेंट की मदद से एक्सप्लेन नहीं कर सकते. Or in notation, you can write the regression model is in that manner. Yeah, or you can say in this manner, y is equals to alpha plus beta 1 x1 plus beta 2 x2 so on plus beta n xn plus slide. Alpha plus beta 1 x1 plus beta 2 x2 so on beta n xn. It is linear function of independent variables. Psilon is error term. Alpha is called as intercept parameter. Beta 1, beta 2 up to beta n are called as slope parameters or regression coefficient. Alpha tells if the value of all the independent variables are 0 or these are at their known level, then what should be the value of. That means alpha ये बताता है कि अगर x1, x2, xn की वैल्यू 0 है या वो अपनी मिनिमम पॉसिबल वैल्यू को ले रहे हैं तो y की वैल्यू क्या होनी चाहिए. Beta 1, beta 2 are the slopes. It tells that if we make a change of 1 unit in x1, then what changes would occur in y, keeping x2 to xn as. That means अगर हम x1, x2, x3, x4, xn को कांस्टेंट रखें और x1 में चेंज करें एक यूनिट का तो y में कितना चेंज होगा, that is explained with the help of beta 1. Similarly, x2 में एक यूनिट का चेंज करें तो y में कितना चेंज होगा, that is beta. And so on we can interpret beta. For performing the regression analysis using SPSS, we go to analyze. Then there is an option of regression in which we select linear. It will open a dialog box, linear regression, and there are two boxes, dependent and independent. So variable for which you want to study the changes, put that in the dependent, and which are causing the changes you will take in independent variable. Then you can click on OK. That is first dependent, then independent, then click on OK. When you click on OK, you will get a number of tables among which we are in. Basically, generally we are interested in three. One is called as model summary, second is called as ANOVA table, third is called as coefficients. First one is model summary, which provides R square, which is also known as coefficient of determination. It tells how much good our model is. हमारा मॉडल कितना अच्छा है. Or we can say how much percentage of variation it can explain in dependent variable with the help of independent variable. That means independent variable में होने वाले variation का कितना परसेंट हम independent variables की मदद से explain कर सकते हैं. If it is larger than 0.8 or you can say 80%, then we said that our model is very much. Also, we can compare two linear regression model with the help of R square. If value of the model for which value of R square is higher, we said that model is better. For one model it is 0.76, for other model it is 0.85. Then the value 0.85 is larger, so we can say the model having R square 0.85 is better as compared to R square equals to 0.7. Second one is ANOVA table. So R square tells whether our model is predicting how much percentage of variation. ANOVA table tells whether our model is fitted good or not. That is, it is a concept of testing of hypothesis. we take that our null hypothesis says our model is not fitted good against the alternative hypothesis that our model is fitted good. Not good, that means all the beta coefficients are equal to 0, and alternative, no, model is good, that means at least one beta coefficient is different from 0. If significance value, or you can say SID value or P value comes out to be smaller than 0.05, then we said that our model is fitted good. Now third table is regression coefficient. It provides the regression coefficients, or you can say estimate of the regression coefficient betas and their significance. So model is fitted good, but whether beta is significantly different from 0 for the population or not. That is tested with the help of table of regression coefficients. So let us fit the model using SPSS. For the purpose, we go to analyze, then to regression, then there is option linear. Click on that. Okay, it will open the dialog box linear regression. First, we study the simple linear regression. We take Fourier resale value as dependent variable, and we are taking horsepower, which was highly correlated with Fourier resale value as independent variable. Okay. Then click on OK. Now you are getting first table as variables entered or removed. So we are entering all the variables simultaneously. So you will get all the variables in variable entered, that is horsepower. It shows only independent variables. It does not show dependent variables. Then second table is model summary. In this we are getting R square, adjusted R square. So we are considering R square, that is 0.591. That is horsepower is explaining 59.1% of the variation in Fourier resale value. Now what is R? What this R signifies? If we are considering only one variable, then it is equal to your correlation coefficient. If you go to table of correlation coefficient, you will see that value corresponding to Fourier resale value, and horsepower is 0.76. Here you can see this one. The correlation between Fourier resale value and horsepower 0.769. So for one dependent and one independent variable, this R comes out exactly equal to simple correlation. It is called as multiple correlation coefficient. Now adjusted R square, when we use the concept of multiple linear regression, then we will discuss at this period. Then we come to another ANOVA table. In ANOVA table, we are interested where other model is fitted good or not. So you can see the significance or P value is smaller than 0.05. We said our model is fitted. That means हमारा मॉडल y डिपेंडेंट वेरिएबल में होने वाले वेरिएशन को अच्छे से एक्सप्लेन करने में सक्षम. Then we go to the table of coefficients. First one is constant, that is alpha. So if the value of horsepower is 0, then the price Fourier resale value of the vehicle will 9.483 thousand. Okay. And when horsepower will increase by 1 unit, price will increase by 0.151 thousand, as Fourier resale value is measured in 1000 rupees. Okay. So we are using the unit 0.151, and there is no matter whether constant comes out to be significant or it comes out to be insignificant. We are not interested in the testing of constant, but we are interested in testing of horsepower. That is independent variable. So it is less, significance value is less than 0.05, 0.05. So we said that horsepower is significant for the model. Now we can include as it is, but what I have told, that R square must be larger than 0.8. It is 0.59. That means 41% of the variation in Fourier resale value is unexplained till. So we include one more variable. Again, go to go to analyze. Then there is option regression, linear, and another variable which was showing high correlation or moderate correlation with Fourier resale value was engine size. So we include engine size as independent variable. Then click on scale. Then you will get this table. Now you can see that R is somehow increased. Initially it was 0.769. Now it is 0.811. Similarly, R square was 0.591. Now it is 0.658. That means when we increase the number of independent variables, R square or R increases. Okay. But while comparing the models, it is not justified that we increase the number of variables, then R square will definitely increase. So which model should be more suitable for our data? Whether a maximum number of variables, whether a minimum number of, that is one variable, some other number of variables, how much variables we should include. So to overcome this difficulty, that it will R square does not depend upon the number of variables as well as number of observation. We use another measure which is called as adjusted R. So adjusted R square is also 65.2%, or you can say 0.652. And for earlier model, it was 0.508. So we can say that our model is better than the first one. Again, both the variables are significant. Model is also fitted good, as ANOVA table is showing p-value is smaller than 0.05. Also, the p-value or significance value for both the variables are smaller than 0.05. So when we said that both the variables are contributing to the model, or we can say that ये दोनों वेरिएबल्स फोरियर रीसेल वैल्यू में होने वाले चेंजेस को एक्सप्लेन करने में सक्षम है. ओके. I am going to explain. Okay. Now we use all the variables which we have taken in the data set as independent variable. But remember, there is an assumption for linear regression that variables should be continuous. Okay. That may, there is a question, what is continuous and what is metric? So metric, which are measured in terms of 0, 1 or in terms of categories. continuous, which is measured on continuous, which can take any value, that is value with decimal points also, that are called as continuous variable. For example, you can take measure height 1.57 meter, that is continuous. Weight is continuous. Money can also be measured in terms of rupee and paise, that is in terms of decimal, so that is also continuous. So let us consider the model including all the variables. Go to regression, go to linear, put horsepower, wheelbase, width, length, curve weight, fuel capacity, and fuel efficiency also in model. Then click on OK. So you can see that earlier R square was 0.811. Now R square is 0.866. That means R square is increased. R is increased. R square was 0.6 something. Now it is 0.7 something. R square is also increased, as well as adjusted R square is also increased with comparison to previous one. So you can say that this model is much better than the previous one. Now we go to ANOVA table. You can see that model is rated good. That means model हमारे डेट y में होने वाले वेरिएशन को अच्छे से एक्सप्लेन करने में सक्षम है for the sample as well as for the population also. R square affect by the change of number of variables as well as number of observations. अगर आप नंबर ऑफ वेरिएबल्स को इंक्रीज करोगे तो आर स्क्वायर इंक्रीज होगा. तो हम कितने वेरिएबल्स तक इंक्रीज कर सकते हैं? ठीक है, तो इस चीज से ओवरकम करने के लिए कि हम वेरिएबल इंक्रीज करते चले जाएंगे तो आर स्क्वायर इंक्रीज करता चला जाएगा. इससे ओवरकम करने के लिए एडजस्टेड आर स्क्वायर डिफाइन किया गया है. ये नंबर ऑफ वेरिएबल्स पे डिपेंड नहीं करता. ठीक है. So for comparing two models, whether one is including lesser number of variables, other is including more number of variables, we prefer to use adjusted R square instead of R square. Now here you can see in table of coefficient, some significance comes out to be less than 0.05, whereas comes out to be larger than 0.05. So you can say that for our model, horsepower is important, engine size is significant, engine size is important, but wheelbase is insignificant. We not have to use it in the model. Similarly, width is not significant. We can remove it from the model. Length is significant. Curve weight is significant. Fuel capacity is also insignificant, and fuel efficiency is also insignificant. Okay, is it clear? Now we include one more variable. That one is remain. Now price in outlet. If you are going to purchase BMW, then its price will always be higher than Maruti. Okay. So when you will repurchase it after 4 years, then price of BMW, resale value of BMW will also be higher than your Maruti. So price of the vehicle is also important for 4-year resale value. Now I am going to include price in thousand also in our model. Okay. Now include price in model and click now. Now you can see what changes would occur in R and R square. R square was 0.76, it will become 0.947. That means now this model is explaining 94.7% of the variation in data set. Listed R square is also increased from 0.711 to 0.943. That means this is better than the previous one. Again, ANOVA table is showing that it is significant. So now when we include price in 1000, what happens to horsepower? It become insignificant. Okay. And similarly, engine size also become insignificant. And the variable which comes out to be insignificant, that is curve weight, that become significant here. Why this is happening? ऐसा क्यों हो रहा है कि हमने एक वेरिएबल इंक्रीज किया और हमारा सिग्निफिकेंस चेंज हो गया? ओके, वी विल डिस्कस इट टुमारो in first session. Okay. Is there any question you would like to ask? Let us take first the offline participants. Offline participants, आप में किसी को कुछ पूछना है? What you want to know about that? Adjusted R square also tells what percentage of variation in Y where independent variable is explained with the help of independent variables. But R square depends upon the number of variables. If you increase the number of variables, definitely R square will be increased. Adjusted R square will increase only when a variable is significant. Okay, that is variable is contributing significantly, only then adjusted R square will increase. When we horsepower, क्या हम उसको separately भी how separately अलग-अलग models can see them separately, you can combine both of them as their correlation with Fourier resale value was high. Okay, so and that is significant. So you can use both the variables in models simultaneously. No, but that will not give correct picture. One will explain around 50%, other will explain around 25%. But combinedly, you cannot say that are explaining 75%. You are getting only 69 point something percent of explanation. Okay, so it will be better you use two variables simultaneously. Any other question from offline participants? Okay. How can we get confidence interval from correlation analysis? I think there is no option for getting confidence interval for correlation coefficients in SPSS. There are other softwares you can use. What is the interpretation of standardized and unstandardized data? It is beyond the lecture. So most probably it will cover in the concept of canonical correlation. That's what is data coefficient and what is stabilized and unstabilized. Now, one question whether is both Excel and SPSS on these data and get same results. Yes, if we use SPSS or Excel, we will get same results. For the use of one variable in model, then some variables are insignificant. One there is no question. You can end the lecture for offline participants saying just writing one answer, and then we can end out. That's very